Alright, we should be live now. We're running at 2,700 kilobits per second. Let's go. Let's see if it holds now. Hello, everyone who might be tuning in from, I don't know, wherever you guys are tuning in from, Twitch or YouTube. We're doing another test stream today to see if we can work and see if we can have decently consistent broadcasting on YouTube. I changed my mobile plan. They said it'd take about an hour for this to work, to take effect, and I waited about an hour. And now we're just gonna wait and see, or test it out now, and see if our upload speed is consistent. And yeah, maybe do some deving while we're at it. Yeah, nothing too crazy today. I want to work on some. Oh, my batteries are running low, so we can't be doing the long stream today either. But yeah, I want to implement some basic mechanics today for the game today. Actually, a simple optimization. I want to do mesh. I want to try doing this occlusion culling type implementation for meshes. So let's see how well this holds up for right now. Let me also make sure my chat thing is working as well, because I don't have to keep changing or switching between windows to try to see what you guys are talking or messaging or saying. So I'm gonna bring this chat box a little bit higher. I'm gonna do a test message here. Why is it saying to enable channels? What are you talking about? What is Restream saying? Streaming on YouTube and Twitch. Go to chat. Should be sent across both. And nice, we have a test message that pops up here. And go to filters and get rid of the chroma key. I think at most I'm just going to do like a simple I don't know, color correction, make it not full transparent. I don't know. Let me do some additional testing here. Filters. Yeah, I'll keep the chroma key. Second. So far, holding pretty consistent on the kilobits per second. Sweet. All right. So I guess we're going to try doing the scary thing, which is actually working, because usually when we start working, that's when the issues start cropping up. So last time we implemented this dynamic mesh generation, which was pretty sick. I was very happy with how well that worked. And I believe I should have pushed or pulled the most latest changes from that branch. If I can check it out. Git log. Let's see what we got here. Scene changes. Yeah, you push the scene changes. So that should be working. In my little cursory test, though, here, it didn't work. So I can either try figuring out what's the issue here, why this mesh is not being generated when we get close to these objects, which is very weird and strange. I'm not sure why there's no mesh being generated. Oh, actually, I think I know exactly why there's no mesh being generated. No, it's because I have some uncommitted changes from home, I believe. Because I was trying to do something here. I remember correctly, we generated a new mesh in the algorithm. No, we set the meshes directly. Filter mesh. Vertices, array, yep. We're modifying the correct data structures here. We do stack alloc. We use toArray, I believe. Yeah, so that's going to create a copy, but whatever, who cares? Yeah, I'm not sure why that's the case, actually, now that I think about it. All the counts should be correct. Let me try. Type. zoom out a little bit so I can see this a little bit better. Yeah. Now we're coding. Let's see, let's first of all get rid of stuff that we don't need to deal with. There's no generated mesh we're inspecting now. There's no need for this mesh gen method. Get rid of these variables here. Get rid of this boolean because we're not doing that anymore. We have this thing. The only thing I could think of is maybe this is for some reason always null and that's causing an issue. This is never called. Oh, right, because I was starting to think about how to implement a better... Yeah, because this is supposed to be happening every frame anyway, so we don't need to do this. Oh, actually we do, Dust Manager. We do need to at least pass in the variable here, so within here we do dust, or what do we call it? I forgot what we called it. I think we called it... What did we call it? He called this mesh gen. Yeah, mesh gen. Generate mesh so we can actually apply the texture. I think that should fix the issue. I just wanted to fix this real quick because I think it's an easy fix. And then I'll try working through the problem space of like this new, yeah, no, the FPS is dropping a little bit. Though I'm not seeing the mesh generation either. What is this null reference that's happening here? Oh, a bunch of errors. Let's collapse this. Get rid of this. Abnormal mesh bounds, most likely invalid vertices. What? We had this working just last stream. Why is it broken now? Why is this broken? I didn't change our algorithm. Fail setting triangles. Some indices are referring out of bound vertices. Interesting. Why are you happening? That should not be happening. But it is happening. That's very curious. Very, very curious. Okay, so far the upload speed is actually pretty good, man. That's crazy. I wouldn't have expected that. But here we are. So, what's going on with our maladapted? Because we haven't changed the algorithm we're using to generate stuff, really. The only thing we've changed, really, has been how we allocate stuff, but that shouldn't be an issue. Try add vertices. We have our get method here. Let's generate some stuff. And then try add value, ref count. Which, by the way, I'm probably going to move this down here. Just so all the utilities are conveniently located down here, and then all the actually interesting stuff is up there where we can easily access it. Now, what's going on with this algorithm? Let's talk about this. We have this whole get player thing that caches it. We have our position, retrieval, we have our gen mesh extents, we have our min x, min z, and then our max x, max z coordinates. Okay, so that's normal, as expected. We have our vertices, which we are allocating on the stack, but we can change that to be, you know, allocated differently on the heap. But honestly, for right now, just to eliminate even more variables in our little murder mystery of how did my code go bad, we're just going to eliminate some of this stuff, remove the spans, reintroduce the arrays, and then change stack alloc with new instead. Shouldn't make anything too crazy of a change, or shouldn't be too crazy of a change, but hey, better to cover our tracks. And then now we're not doing this additional allocation. Sweet. And then now we have our try add vert. Awesome. And then what does it do? It iterates, returns I, returns old, increments the current value of the index. Yep, it behaves exactly as we'd expect it to. So it's saying there's some weird stuff happening with the indices that's happening when we set the mesh value. The only weird thing I can think of is maybe the fact that we're not generating a new mesh, but that seems dumb to do that, to generate a whole new data structure just for that. So I'm going to assume that's not the problem here. So what could be the problem? What could be the issue at hand today? We have our tries, try counter. We're incrementing it after every single call. We pass each vertice for the mesh in there. We have our points 1, 2, 3, 4. Very cool. Yeah, the algorithm I don't think is that crazy. I think at most we can do like maybe filter dot mesh dot recalculate bounds, but I don't think that should be needed. We're not using the bounds for anything, so I don't know why we need to recalculate it. What's happening on starts? We add these components. Oh, you know, I changed also this to awake, I think. Or maybe it's supposed to be awake. So we add the components. We load the material to apply to the geometry. We check to see if source is null. It should no longer be null. We should be actually entering the point mesh. 1 second. Feel the burn. I'm trying to feel the burn. It's good to see you, man. Also, the upload is surprisingly consistent. So I guess switching to this plan was a win. I think that was just what we needed to do. And then what else do we have going on here? Executing generate mesh, point mesh gen. And this is a misnomer. We should need to change the name of that, but we'll do that later. We have our correct constants. The try index count is correct from our little formula we derived last stream. Yeah, there's nothing here that really spells out like there's a smoking gun here of what the issue is. And it might be one of those weird things between Windows and Linux. Because we had that issue with my... Oh, no, it's working now. So I think maybe it was just the data structure. The fact that we're using stack alloc instead of generating onto the heap. Or maybe just recalculating the bounds fix that. But cool, we have our mesh generation working. Cool. Or we fixed the thing that wasn't supposed to be broken in the first place. And it's performing the way we want it to. Cool. Now we have that working. We unbroke the thing that wasn't supposed to be broken in the first place. Maybe it's something to do with Windows. I don't know. Maybe the way Linux does things is different than how Windows does things. We're going to have to see how this is going to work on the Steam Deck, but we'll deal with that later. Alright, let's just add our changes before we move on. Git add all. Git commit. Hopefully you're doing good, Terrell. It's going to be good to see you and play some games later. I'm hyped for that. It's always a pleasure every time you hit me up with that. Get commit. Broken code. I need to think of some cool places to try this stuff out too. The streams. Now that we can go anywhere. Now that we're unbounded, it seems. Maybe go to a sewer or something. Or McDonald's or... I don't know. A nature preserve. The possibilities are endless. Anyways. So we have this thing, right? And now we're at a crossroads in terms of what we can do in terms of implementation. We could do... Option 1. We pull out some grid paper. and we start defining an algorithm for our cellular growth so that we can start defining the rules of how the player pushes around stuff, the miasma or the dirt or whatever. Because currently the way it works is that the player, wherever the player steps, they just clear up that area and we lose volume. So, there's no preservation of volume that's happening here. The player just deletes everything that is in his wake. So, what we want to have happen instead is some kind of algorithm that when the player steps on a dirty cell, we actually push that volume somewhere else. So the player can actually like group and move things around. So there's some still kind of a concept of preservation of volume or space. So that's option one, defining a new algorithm and how we're going to deal with that. Option two is we can work on this separate thing, the separate optimization, and implementing our own kind of system for occlusion culling, so that when you're in a map, instead of rendering everything that's in the map, we instead can have sections. Sections are going to be rendered and sections that are unrendered, and these sections become rendered only once the player enters that certain area. Or maybe we do a thing where we preload that area or something, so that if there's a possibility of the player seeing that area from over here, like if you have area 1 and area 2, and the player can see area 2 from area 1, then we should load area 2. Or we just make it like a hard, fast rule that we only load the current area the player is within. I think that should be kind of simple. Those are famous last words. Thinking, oh, a feature to implement is going to be super easy. It's going to be easy to add that to the game. And then it turns out, it's actually a 3-month side quest. But that's an option. And I already have some idea of what I want to do in terms of implementing that feature. So it shouldn't be that crazy to do. Maybe I just do that. Because defining like some kind of cellular algorithm requires, I have like some note paper we can draw on here. Or I guess we have Miro as well. Well, Miro is an option that exists. I could just go bam, bam, Miro. No, that's, what is that? Expedia? Why am I, no, get out of here. I could go to Miro.com and I could, oh, you forgot who I am? You forgot who I am? Fantastic. Let me log into the company. Let me log into my company account. 1 second. But yeah. It shouldn't be that complicated to do this occlusion culling implementation. I don't think it should be. I think it might be just simple as like a graph theory thing or a bounding box to me. Just when we started praising the internet for being consistent, we lost it. But we're back, I think. We should be back. Yeah, we're back to it. It finally cracked. Yep, it finally cracked. The internet finally cracked, but we're back. So it wasn't that bad. It wasn't that bad of a crack. Last time it was like periodically, consistently, every 2 minutes. Yep, it finally cracked. The internet finally cracked, but we're back. So it wasn't that bad. It wasn't that bad of a crack. Last time it was like periodically, consistently, every 2 minutes, the internet would die. We managed to go like, what, 19 minutes without the internet? Again. Dude, it's happening again. Not like this. Okay, I'm going to blame Miro. I'm going to say Miro is the problem here. So we're going to close Miro. Because everything was fine until I opened up Miro. Everything was fine until we opened up Miro. So I'm just going to keep closing things so we don't throttle our internet. And hopefully that's enough to like stay us. Hopefully that's enough to keep us from the bad times. But right now we're green, so okay. Anyways though, But yeah, like this is still Unity. This is Unity. Let's actually finish a game before we go into let's finish a game before we actually start exploring the custom engine thing. It's gonna be one of those days with 50 plus streams showing up in the channel VOD tab. Yeah, that's the worst. Hopefully it's not, because it reconnected. Usually that only happens if like it hard disconnects for like a couple seconds or something, or a minute. So far we've been recovering, so I'm optimistic. This is sick though. But yeah. Oh, okay, so I guess we're not going to do the Miro thing, because I don't trust Miro. I think that's what tanked us. I need to find some kind of offline application to handle this, to do this kind of content. So, at least to do scratch work. I think that's what's needed here. I need to have some kind of offline tool I can use to do some scratch work, and explore these ideas for implementation. Either that, or I just pan the camera down and use my notebook that I have here to like actually illustrate some of the ideas we have, which maybe might not be a bad idea, honestly. It's just that you're gonna have to use like, I don't have one auxiliary camera just for that kind of thing. Oh my goodness. I don't have like one auxiliary camera for that kind of thing, so it's a little bit sketch. It's a little bit sketch. But I don't know, we can see what we can do to illustrate some ideas. I have actually some grid paper which works perfectly for what we're trying to describe here. So either we do that. You know what? Screw it. We're just going to do the thing. We're going to do the occlusion thing first, because I think it's going to be straightforward, and if it's not, then we can always... Occlusion system. We could always just not do that. I could always switch back to algorithm planning. But yeah, for now we're gonna try this out. It's gonna be great. We should be happy. And we have our occlusion. I called it occlusion system. That might be a misnomer, but whatever. We'll live. Anyways, so let's think about this. How do you want to think about this? We should have one general system that's like a manager that's going to contain all the areas that need to be occluded. So I want it to be as easy as like just adding a component to a root level game object, and then it's just going to get all mesh renderers that are children of it on start, which might suck, but whatever. We have loading screens for a reason, and it's a one-time cost to do that. And then from there we just have this one general manager that can do it. So we're gonna need like two things here. We're gonna need like, we have the occlusion system, and then we have an occlusion space. C# occlusion space. So we have like two components to worry about here. Two components to worry about. Not the end of the world. I mean, I might have to think through this a little bit. But okay. So we have this space. We have this occlusion space, and we have occlusion system. Maybe we even want to rename it to occlusion manager. Come on. Don't do this to me. Nope, that's not what I want. My shortcuts are all broken. Close. Exit. No, I didn't want to close the code. I want to close that. Okay, thank you. Thank you. Occlusion system. Yeah, we'll just change this to... Can we not alt? How do you refactor a name? Whatever. So we're going to have a list. It's going to be a serialized property too. A list of occlusion spaces. Okay, spaces or bounds, that might be a better way of describing it. In fact, I might have to do some renaming. Bounds. And then these bounds, we're going to have to do a thing where everywhere the player goes, we're going to check to see where exactly they are and whether or not we need to invoke a bounds, or how should we do this? So let's like define an API, right? I think that'll be the simplest way of going about this. Just defining a general API for how we're going to be interacting with things. So we should listen to say public void on new bounds activated. All right, and then let's look at the individual spaces. So we're going to have like a private list of mesh renders, and then we're going to set this on probably awake. And then we're going to just do renders equals game object or get component in children. A little bit of a nasty thing. It's going to chug a little bit, depending on how much objects we have. But hey, you got to break a few eggs to make an omelet, right? And instead of making this a mesh render, we should just make it just render in general. Make it very generalized. And then do we just make it an array? Might be just an array. I don't know if it's my rendering that's froze the screen or your ISP. I didn't get a disconnect thing. We seem to be going good still. So hopefully it's just your end. Hopefully it's just your side that's bad and I'm great. And it seems to be the case. Or I'm being gaslit into thinking things are working better than they should be by my service provider. Hopefully it's that. Hopefully it's not that. Private renderer. Yeah, what's the issue here? Cannot convert type unity render to... Oh. Get components. That's what I need. Get components in children. Perfect. And then you could just have like a simple method, activate and deactivate, which will just iterate through all the renderers and enable them or disable them so that things aren't visible and things aren't being drawn. It's my rendering. My laptop's struggling hard. Okay. All right, thankfully. Activate. Oh, what's the word I want to use here? Activate rendering. Deactivate rendering. And then here's just going to be simply iterating through. No, we're not. I hate this auto detection crap. It's terrible. Render. What do you mean renderer 1? Just renderer. I don't care if I'm covering something. I don't care. Activate. I think enable should work. And then deactivate's going to be setting this to false. Alright, simple. Nothing crazy. So on whatever component, we're going to attach this to like the root level of like, you can imagine your scene or level being a collection of like a bunch of chunks of levels. So like in the level we had for the demo for SteamWorld Prototype, there's like 3 sections you can really think about, or maybe even like 4 or 5, depending on how you split it. But you can have like the intro area and then like the factory area as two discrete occlusal areas. So we can have, instead of having all the assets exist just at root level, we're instead going to have like, for the intro area, have one parent that's going to be the parent of all the objects that are going to be in that intro level, and then another one for the factory. And this is going to iterate through all the children of that level and then deactivate all the renderers. So if we're in the factory, we don't need to see all the stuff, we don't need to render anything from the intro area. This is what this serves. We don't need to see all the stuff, we don't need to render anything from the intro area. This is what this serves to do. So we attach this to the root level, it gets all the children renderers, and then we'll enable them or disable them whenever that matters. We have this data structure here for occlusal spaces. I'm going to just keep this simple. I don't want to have to do annoying managerial stuff with this. So we're going to do like a public static occlusion system instance. Heck, maybe even like make it internal. Really keep things stupid simple. Private static occlusion system instance. And then we're gonna, like so. And we're gonna set it here in awake. And then, even though it runs on Windows 10, I miss my PC, Tails. I miss her a lot. Even though it runs Windows 10. I mean, isn't that like a sell? Isn't that an upgrade? I prefer Windows 10 over 11. I feel like Windows 11 is just a bad selling point. We're going to make a public static function here. Public static register. Or add. Yeah, just register actually. There's a one-time process. And it's going to be what? Occlusion. Occlusion space. We'll make better names for all of these components later. We just need something for right now. And then we have this is going to be private. Bounds. And then we're going to do also naming convention. We're going to do s_instance add bounds.add space. Perfect. And sure, we can make this a read only just to be even cleaner. Even cleaner. And then on awake, we assign s_instance to this. Life is good. Everyone's happy. And then on new bounds activated, yeah. But the end of support makes it a detriment if I ever manage to get it set up again. I mean, at least the Windows 10 end of lifetime is like extended for like 2 years, I think. For like $5 annually. That's not the worst thing. And then like on top of that, once end of life arrives, like what's going to happen? Microsoft is not going to bust into your house and take your laptop. It just means that you maybe got to be a little bit careful, and then maybe eventually some applications may not work as good. But like Windows 10 is not going to be that drastically different from Windows 11. Hopefully, in terms of how your applications work. So I don't know. It's not that big of a deal. I know, like, I have one laptop that's running Windows 10, and we're just going to keep that bad boy running as is in cryostasis, and then maybe occasionally let him have access to the internet on a good day. But have access to the internet. But even then, I'm just like, no, you stay in your 2016 state. and you never get to leave that. You're stuck in cryostasis. So okay, we have our data structure here, but now how are we gonna know when to enable these things? Because there's a lot of considerations that happen, right? Like, you don't want to have, as a player, like, the player can be here, and then they can enter a corridor into the next area, and then, like, okay, if you go just based off of when the player is adjacent to an area, then, like, you have this weird visual artifact issue where once they get past the threshold, they're looking at the void, and then all of a sudden, all these environments pop up. That's not great. So you may want to have a concept of nearest neighbor to associate this stuff. Oh, look, someone's getting married, or someone got married. Congratulations. But yeah, you may want to have the concept of like a nearest neighbor, in which case we have to do some kind of graph data structure, which I'm not sure if I want to do that. Not only like to implement that, but also as a designer to have to actually maintain that data structure in the scene hierarchy. That's dumb. We can look for like nearest neighbors by space. That may have some weird connotations as well. We can have like a box and do raycast up, down, left, right, and then find the nearest one like that. And that might be better than using a transform center position to determine nearest object. I don't know. There's a lot of ways we can tackle this. A lot of ways of going about it. We can just focus on just keeping the current player activated, or just doing a check with position of the player to see which one to activate, which then requires kind of having a bounding box built for each space, so we can test the player position relative to that. There's a bunch of ways to go about this, and it really depends on how I as a designer want to do it. We can have it, and this also determines what kind of restrictions I as a level designer I'm gonna have to deal with. We're gonna make it where you can't freely explore worlds, but you instead have the different parts of the level. Instead, you're gonna get to the corridor, then have a transition happen, and then you end up placed in the next place with everything that's meant to be visible. If we do that, we have to have some kind of indicator of which space you're going to. That's kind of annoying. I think... Yo, what's up, Kieran? Good to see you. Hopefully everything's good over there. It must be pretty late, I imagine. Hopefully it's not too past your bedtime. Oh, yeah. So many different design considerations to deal with in terms of how we implement this. So many design considerations. In fact, let's like list them out. Let's list them out. There's like general design considerations, and then there's like implementation branches we can take in terms of how we do this occlusion system to optimize and minimize draw calls. So on the design side of things, we have the option of defined entrances / exits, teleport or transition to the next area. My PC and laid on the bed. It's 2 a.m. here. Oh snap, dude. So you're just clocking out from the day of game deving or gaming or schooling or what have you. And you hop on in bed just to see some more programming content. You're just like me. You're just like me for real, for real. Some days I get off streaming and it's like 1 or 2 a.m. and then I just pull up like Dave Plumer's videos about like developing Windows and just see some random content about C++ or optimizations or whatever. It's fun, man. Anyways, though. But yeah, option 1. So you have an area, you get to the end of the area, entrance or exits, and then a transition happens, we cover everything, and then we enable the next area, and then we place the player where they need to be. I don't like that as much. It makes things feel very boxed in and not free-flowing. You also have to define these entrances and define their targets of where they're going to go to, so that's annoying as well from a design perspective. There's probably ways around it to not make the implementation that crazy, but still like extra work the designer would have to do in this system. So there's the other option of like loading neighbors, loading neighbor areas. So instead of having defined transitions from one area to the next area, we instead have defined we dynamically calculate which area the player is close to going to, and we activate that so that the player can just dynamically move there. There's no break in gameplay loop or anything. It's just they went from this area to the next area, and we load it by the time they get there, so it seems seamless. It means that we have to have some kind of way of calculating which neighboring space is the player, or let's say room, which neighboring room is the player closest to, and then we activate it for rendering. So that by the time if the player decides to move there, then we have this. The one issue is that we might run into that case where we kind of defeat the purpose of this, where we end up rendering things that don't need to be rendered because the player ends up not going there. So an example is like, let's say this is an area, and then this is another area, and there's another area on top here as well. Well, the player might go here, and we might load it thinking that, hey, they might be going to this area here. But instead, they actually just are doing stuff here for whatever reason. And then they actually end up going up here. So, okay, awesome. So we enabled all this for rendering, even though the player didn't actually end up going there, and that may or may not incur some costs, right? Especially if it's within the area of the cone, if it's within the Frustum cone. So, okay, there's some downsides to that. We could try to mitigate it though. There's ways of definitely mitigating it. I kind of like this second option. And now, if we go with that second option, we're faced with this new design decisions we have to make, which is, okay, how do we want to implement this neighbor detection? Because we have to have some kind of reference to the neighboring spaces that could potentially be entered by the player. So, depending on what we're going to do, if we're going to have like verticality, up, down, left, right, we can't use just like, hey, down, left, right. We can't use just like, hey, or maybe we can actually, like, we have the player's position at all time, right? And we can check to see if the player's within this bound and activate it. That's how we do it. And then we can also try, if we have the bound that the player's currently in, we can iterate through the other ones in some kind of form or fashion. So one idea I had is that, like, for every activated bound, out and find the adjacent left, right, up, down, forward, back neighbor space to it. That way we don't have to like manually set those things. It can just be programmatically done on a wake. That's one option, having that kind of collision volume there. Or generate a bounding box and then test that to see if the nearest ones. That way you don't have to do a bunch of dumb computations for every single player movement. Yeah, that wouldn't be that crazy. But it seems like no matter what, we're going to need to have some kind of concept of a bounds here. So let's actually just implement that, right? Let's just implement this. So every single occlusion space needs to have some kind of bounds. And then the other question is like, all right, are we going to do like axis aligned bounds where everything's in world space? I don't know. Let's see. Maybe we'll start with world space bounds just to keep things easy. It will result in levels that are more grid-like or aligned to a grid, but I think that's not the end of the world. We can start with this and then maybe add local space stuff, transformations, just to be fine. What are we gonna do? Oh crap. If we do the bounds thing, we're gonna have to... Okay. We need to iterate, because we can't just choose a random bounds like 0, 0 and then expand it. We have to actually position it into one of the bounds that exists. Like use the first element and then set the bounds to that and then expand it as we have more. So, okay, we're going to do that then. So we're going to do bounds, and then once we do get children, we're going to iterate. Or actually, we can just build the bounds here. What am I doing? Yeah, we're going to do it here. Renderers. What? Dude, get out of here. Your autocomplete is terrible. I can't believe people keep saying, like, talking about AI taking over programming when you can't get IntelliSense or autocomplete's working actually good. Okay, if bounds, we're going to do some fancy stuff. Bounds, null, equals. So if bounds is null, we're going to use render 1, which is a stupid name. I don't know why. I don't care about including that. Dot bounds. Why are you angry at me? Why are you mad at me? What have I done to anger you? It is a nullable reference, but bounds is not a struct. Or is it equal null null? No, I'm pretty sure it's equal null. Is bounds actually a struct? Have I been deceived this entire time? Let's see. Let's